Okay, this is 7-3 double angle formulas. We're developing formulas again. This time it's actually quite a bit easier because we're going to use the ones we developed yesterday. So the lesson I don't expect to be as long or as tricky. So let's start. From your work with graphs of trigonometric functions, you already know that f at theta is equal to sine. I'm going to call that x from now on because I don't like saying theta. I always confuse it with pi. So sine 2x is not the same as f at x equals sine x. So we know that this value here is the k value, right? And what does the k value do to our graph? Yeah, Elijah? Yeah, horizontal compression, or changes the period. More specifically, we know the period is equal to 2 pi over k. So if we have a k value of 2 here, we know the period is actually going to be cut in half. Okay? And that's the relationship that we should already have memorized. So we can see that then in green here. We can see that our regular graph, the blue one here of y equals sine x, looks like that. Y equals sine 2x is the red graph. And then when we have amplitude of 2, that's our red graph here, which is the same period but a higher amplitude. Okay, so we know there's a difference between this and this. F at x equals sine 2x is the graph of y equals sine x compressed horizontally by a factor of a half. F at x equals 2 sine x is the graph of y equals sine x stretched vertically by a factor of 2. Okay, I'll review up until now, so it's all good. How are the trigonometric ratios of an angle that has been doubled to 2x related to the trigonometric ratios of the original angle x? So it says, given 2x equals sine x plus x, use the appropriate compound angle formula to expand sine x plus x. Simplify both sides to develop a formula for sine 2x. So who remembers the formula now already for sine x plus x? Who remembers what that formula looks like? This is just from yesterday review. Yeah, Gianluca?
Sine x cos x.
Yep.
Plus cos x sine x.
Okay, and I hope everyone remembers that, because you're going to have it memorized for tomorrow when we write the quiz. Okay, so remember the pattern is with sine, the trigonometric functions are different, but the sign is the same. So kind of remember that by thinking sine, it sounds the same as sine. The signs are the same, but the trigonometric functions change. For cosine, the sign is different, but the trigonometric functions are the same, right? So cos x plus x would be cos x, yeah, cos, and then the opposite sign, sine. Okay? And cos, sine starts with sine, cos starts with cos. Okay, in the actual formula itself. All right, simplify both sides to develop a formula for sine 2x. So if I simplify the right-hand side here, this is obviously sine 2x, just adding those two x's. Now sine x cos x plus cos x sine x. These, of course, are the same, right? So we get 2 sine x cos x, right? Because it doesn't matter the order in which we multiply, right? When we multiply, we can change the order. 3 times 5, same thing as 5 times 3. So these two expressions are the same. Any questions there? All right. Next, it says simplify to develop a formula for sine 2x. So there's our formula. Done. Verify your double angle formula for sine by graphing each side as a function on a graphing calculator and examining the table of values. So we can try that. Let's give a random number. Somebody try sine 53. What's sine 53? Just do two decimals.
0.39.
Okay, so sine 2 times 53 divided by 2 is 26 or 26 and a half, right? What's that, Daniel? 2 times sine 26 and a half, cos 26 and a half. And I'm working with degrees, so make sure your calculator's in degrees.
Didn't come out to the same thing, hold up.
Yeah, because
You in radian?
sine 53 radians. You said-
I'm in degrees.
Yeah, but that's sine 53 radians.
So sine 53 degrees.
Oh, now it did, yeah. No, it was right.
What is it?
Yeah, it came out to 0.39.
Okay. Sorry, Luke, what were you saying?
Sine 50. I got that.
Yes,
Sine
sir.
53 in radians, not in degrees. Yeah.
Sine 53 in degrees is 0.798. So 0.8.
7.
That.
And this is...
That's the same thing.
Okay. Alright, we'll make sure we don't ask Daniel again.
Okay, so you're right.
I'm just kidding. Okay, yeah.
Sir, okay, how did you go from the original sine x plus x to the sine 2x formula?
Because x plus x is 2x.
Okay.
That's all I did. I added the x's.
Oh, okay. Wait, then shouldn't the sine 2x be 2 sine x plus cos x, or?
Here?
Yeah.
No, because this is the same as this. So 1 sine x cos x plus 1 sine x cos x is 2 sine x cos x.
Oh, okay.
Right? This is the same as this, right? These are the same. Right?
Yeah.
So I have sine x cos x plus sine x cos x, 2 sine x cos x.
Oh, okay.
Okay?
Okay.
Any other questions about that? Okay, so that double angle formula works. It's very simple. If I ask you on a quiz how to develop the double angle formula for sine 2x, I hope most of you will smile and say, well, that's probably the easiest one we've seen so far. Okay? And you would make this statement based on what we learned yesterday. Okay? And you could say, you know, based on the cosine law, based on the length of a line, we developed this formula for some, and then we develop that. Okay, verify your double angle formula, done. Verify that your double angle formula for sine works by evaluating both sides of the formula for x equals 45 degrees. Repeat for x equals, okay, I think we're good with that. We verified it, we're good. Repeat parts A to C to develop a double angle formula for cos 2x. All right, cos 2x is going to be cos x plus x. Who remembers that formula? Nobody? You guys did hours of homework last night, Marco.
Cos x minus sine x.
Very easy formula. Okay, so again, pattern to memorize. The sine is different. Okay, it's cos, so the sines are different. The trigonometric functions are the same. Okay, there is a very nice, easy pattern to remember these things. So cos x times cos x is what, Luke?
Pardon?
Cos x times cos x is what?
Cos 2x.
No. Right.
Okay.
Sine x times sine x. Okay, when you have a trigonometric term squared, for some reason the nomenclature is to put the square in the middle like that. Okay, instead of writing this, both are technically correct, but the standard is just to write it in the middle. I guess it's just a little quicker, saves on the brackets. And if you were putting it up here, right, you would think it would be cos x squared. So that's why they write it in front. You guys get that? They put it in the middle because if you did that, you would get it confused. Okay? And they don't want to write the brackets every time, so they put it in the middle, and it's easier. Okay? So there's our cos 2x formula done. So far, double angle formula is a lot easier than yesterday. Repeats parts A to C. So now we want to verify this. So somebody give me an angle. Ramon wants to do cos 68 degrees, which is equal to cos 2 times 34 degrees, which is equal to cos squared of 34 degrees minus sine squared of 34 degrees. Cos 68 is what, Daniel?
Oh, not this one. 0.37. That's right.
Okay, and cos 34 squared. So make sure you do this right. You got to put in the brackets, okay? If you put cos 34 squared, it might square the 34, depending on your calculator. So put bracket cos 34, close bracket squared. Actually, if you have a square button, it should pick it up. Sorry?
I do have 0.37. So you're supposed to get.
Okay, somebody got a different answer? Probably in radians. So you got to check your calculator. Good for everybody to practice, right? To make sure that, you know, before you write the quiz or the test, you're actually consistent in doing these type of, you know, calculations with squaring trigonometric functions.
So the whole thing is squared, right?
Yeah.
Okay, so
Okay. E. Use the identity sine squared x plus cos squared x equals 1 to eliminate sine x from the right side of your formula in part D. Verify that your new formula is correct by graphing and by substitution as before. So we want to eliminate sine x from the right side of our formula. So from this sine x we want to go away, and this sine x we want to go away. Okay, so let's look at that. I'm going to zoom in here. It's a lot neater. I'm running out of space. Okay, so sine squared x plus cos squared x is equal to 1. Therefore, cos squared x is equal to 1 minus sine squared x. We're just moving this over to the other side.